visualizing NASA's zeros and ones for the rest of us. I'm Tonya Hall, and joining me is Ernie Wright, visualizer at NASA's Goddard Space Flight Center. Welcome, Ernie.
Thank you. I'm glad to be here.
So, give us a brief summary of your multimedia background and your role today at Goddard.
So I work in the Scientific Visualization Studio, and we call that the SVS, so we don't have to say that over and over. The studio creates scientific animations and illustrations using data from NASA missions. And these are videos that are specifically data-driven. So everything you see is a piece of data from a NASA mission. I work specifically with Lunar Reconnaissance Orbiter. LRO has been in orbit around the moon for 10 years now. We just celebrated our 10-year anniversary. So I get to work with a lot of very cool moon data. LRO is mapping the moon with 7 different instruments. And I get to sort of display that data to the public, which is great.
We've been celebrating the 50th anniversary of Apollo 11 mission all across the world. And I guess my question for you would be, how did you contribute in helping NASA commemorate this milestone?
Well, this is a very personal thing for me because I was 6 years old and remember when it happened. My dad woke me up when they got ready to do the moonwalk. It was really late at night. It was about 10:30 at night when they were about to come out. So I knew something special was going on. For the 50th, I've created a number of visualizations of the Apollo 11 landing site and of all of the landing sites for Apollo, because we're really in this sort of 3-year season of Apollo that we're celebrating. And in the past, I've done things with Apollo 8, like the Earthrise image that Apollo 8 famously took. So we've collected all of that together and made sure everybody had access to it, so that, you know, LRO, being the moon mission now, can play a role in celebrating this amazing milestone.
You start with, as you mentioned, a ton of data, and you figure out the best way to present it. So what is the process like for a video series like the magnetic bubbles on the moon?
Well, our job basically is to place that data in context. I mean, when it comes from the spacecraft, it's all just zeros and ones. And so we like to put it in its geographic location, and we like to make it look a little bit like whatever the data is. So if it's something hot, we'll make it red, and if it's water, we'll make it blue, just so it reads for people, and it's easy for them to interpret. And we also are storytellers. You'd think we could just paste this data onto a ball and say, you know, here it is, but we really have to tell the story of the data, what it means, what its significance is, why people should care about it. And so we collaborate with producers and writers and scientists, and we all get together and decide how to present this data in a way that's engaging for the public, in a way that is comprehensible to a public that may not have all the science and technical background that the scientists do. So I have to translate the data into forms that my software can understand. We use basically movie special effects software. So there's no science sort of built into the software. I have to tell it what this data is. And so I make it into image maps and things that can be wrapped onto geometry. And then that software is like having a movie set. So there are cameras and lights, and you decide where to point the camera and how the light should be pointed. Usually it's sunlight, but sometimes it's something else. Sometimes we'll show the data being taken, and so you'll draw a swath around the surface of the moon, whatever tells the story. And we call this cinematic visualization. We kind of want to distinguish it from the kind of things that scientists might do at their desk, where they would plot graphs and make things that only scientists love. We're making things that try to communicate to a much wider audience.
Let's talk more about that. You're a visualizer and storyteller behind hundreds of NASA illustrations and videos. Explain the process behind building.
I feel old.
Well, you're not.
Hundreds.
I want to understand the process behind building those mapping videos you discussed. Let's go talk about the July 2019 solar eclipse that took place in South America.
Right. That's kind of an unusual case because I'm creating the data myself. I take, we call them ephemeris. This is a listing of the positions of the sun and the moon, and sort of the orientation of the Earth, which way it's spinning. And I perform a calculation that finds where the shadow is. It takes billions and billions of little arithmetic operations to figure that out. But once I have it, I have this map of the shape and the position of the shadow. And then I have to decide what sort of picture of the Earth do I put underneath of that? Do I make it look like a map, or do I make it look like the real Earth? And then, the shadow moves over time. And so you want to kind of think of a way to represent that as well. So what I've done is draw the shape of the shadow every 3 minutes or every 5 minutes. And so you get this sort of oval overlaid on top of the path. And then you put the times on there, and that tells people where to go, where to look, how long it's going to last. So the eclipse map is unusual, like I said, because it's not data that I get from somewhere else. I made it myself. I did the calculation that makes that data. But in other ways, it's very similar. I mean, once I have the data, I put it into a form like a TIFF image, just a 2D regular image that the rendering software can understand. And I make sure that it's in the right place on a sphere, and then I decide where the camera has to go in order to tell the story.
You mentioned software a couple of times now. What software tools do you use to organize the data that you're referring to and build those images?
So a lot of us have a background in computer science, and the reason for that is that we have to write our own programs to translate that data. It always comes to us in some weird form that no software can read except the scientist's little desktop thing. So we're constantly having to write software that translates the data, interprets it. And so we use half a dozen different languages. I write the Eclipse software in C, but we use a language called IDL that's very good for image processing, image analysis. We use scripting languages and Python, and all of that's like the first step, just to get the data into a usable form. And then we use off-the-shelf animation and rendering software. So we happen to use Maya for animation. This is the program that sort of displays the set. It has the models in it and the positions of the camera and the lights. And the rendering software, the software that actually writes the pixels into the final image, is RenderMan, which is a piece of software that Pixar makes. It's the same software they use for their movies.
Very cool. You mentioned that you work a lot on the Lunar Reconnaissance Orbiter project. What is that like?
Oh, this is an amazing team, and I know you've spoken to people who work on it, including the project scientist. It's a great team to work with because I grew up with a love for Apollo and lunar exploration, and kind of got that from my dad. It's great for me personally to sort of return to the moon in this way and work on that data. And LRO is generating more data than any other planetary mission has, partly because it's closer to the Earth. So the bandwidth on Apollo is about, the bandwidth on LRO is about 500 times what it was for Cassini. So all those beautiful pictures of Saturn, it was like downloading from a dial-up modem. So, as lovely as they were, they couldn't send us as much data as LRO can. LRO sends gigabytes of data every day. So we're building this huge archive of data about the moon that's going to be used for the next 50 years at least, mapping the surface in visible light with cameras, and using lasers to map the shape of the terrain, using an infrared camera that can tell us about temperature and rock abundance. This is a thing that you use to figure out the safety of a landing site. If there are boulders everywhere, you kind of don't want to land there. You want to land on a nice flat spot. And several other instruments. There's an instrument that's measuring the radiation environment in space around the moon. And that's really important for astronauts. You know, how long can we stay there without hurting ourselves? How much shielding do we need in order to stay there for long periods? So it's fascinating for me to be able to sit in on the gathering of all of this information, and then to be able to sort of translate it into forms that everybody can see and appreciate.
How does your passion for amateur astronomy manifest itself, if you will, in your work?
I think it's helped me a great deal. I know what the moon is supposed to look like. That sounds a little silly, but if you've looked at the moon through a telescope, you have a good idea of what it should look like when you render it. And if the color's not right and the shadows aren't right, you know right away. So I've actually done some astrophotography in my backyard, brought those pictures into the office, and compared them side by side with things that I've rendered to make sure that I'm getting the shadows perfectly accurate and figuring everything out that I need to. And the other thing is, amateur astronomers love looking at space stuff, and that's my job all day. And then I can go home and look at it for real through the telescope. So, you know, what could be better than that?
You're a lucky guy, Ernie. That's all I'm
Yeah, I
going to
know.
say.
I feel so lucky to be in the position that I am. I don't have to do the hard work that scientists do. But I get to sort of be science adjacent. I get to sit right next to them and talk to them about their results. And a lot of times it's before the public knows about them. And I get to make things that are beautiful that engage the public. So how could I, you know, this is the luckiest job for me. I even got to meet a couple of Apollo astronauts. So yeah, it's just an amazing thing. And I feel fortunate every day to be doing the job that I'm doing.
Well, thank you, Ernie, for sharing some of that with us. That's Ernie Wright, visualizer at NASA's Goddard Space Flight Center. If somebody wants to connect with you, Ernie, maybe they want to see, if I have more questions about how you do your work, how can they do that?
I think I should say, first of all, that they need to visit the SVS website. So that's svs.gsfc.nasa.gov, or they can just put NASA SVS into their favorite search engine. It's usually the first thing that comes up. If they want to contact me personally, my contact information is on the website, and you can search for my stuff just by putting my name in the search field. And it'll tell you how to get in touch with me and also show you the things that I've done.
Sounds good. And you can find more of my interviews by going right here or tonyahall.net. Thanks for watching.